This is Tech Math 2, and we're in section 1-4, which has to do with measuring things. Measurement. Not too bad. So now we have a situation. We could have exact numbers. Alright, so I ask how many pennies are in your pocket, and you say you have 2 cents. That would be an exact answer. If I asked you, if you took those 2 cents and you put them one right next to the other, what would be the length of the 2 cents? That would be an approximate answer. That'd be an approximation of the answer. So if you came up with 1 1/2 inches, that doesn't mean it's exactly 1 1/2 inches. That means that as best as you can measure it with the instruments you have, that would be the case. The next issue in the chapter has to do with accuracy. And significant digits. So if I had 2.5 miles, 2.5 miles, I would have significant digits. I would have 2 of them. 2 significant digits, but my accuracy would be 1/10 of a mile. I couldn't tell you that it was 2.51234 miles. I can only tell you to the nearest 1/10 what my accuracy is. Now we have rules for significant digits. So on page 15 of the text, we have some rules dealing with significant digits. And the rule 1 says all non-zero numbers are always significant. So if I had 1, 2, 3, 4, then each of them would be significant, and the 4 guy would be, I'd have 4 significant digits. If I had 1, 4, 8, 0, 3, I would have 1, 2, 3, 4, 5 significant digits. If I had 1, 4, 0, 0, 0, well, the zeros are not significant. Only the 1 and the 4 are. So I'd have 2 significant digits. In the case of the number above, the 0 is sandwiched between an 8 and a 3, so I have to count as significant because the 3 is as well. All non-zero, all zeros are significant if they are between some number. So that's rule 2. A 0, if I want a 0 guy, so I have 1, 2, 0, 0, 0, 0, 120,000. I show 2 significant digits. If I wanted to show 3 significant digits, I'd put a bar above there, and then I'd have 3 significant digits. If I wanted to show that this number is good to 4 significant digits, I'd put a bar there. If I wanted to show it to 5 significant digits, I'd put a bar there. I could put it in scientific notation, and that would be 2 significant digits in scientific notation. That would be 3 digits in scientific notations that are significant, and that would be 4 digits in scientific notation of significance. So I have 2 significant digits, I have 3 significant digits, I have 4 significant digits. Okay? Zeros to the right of a whole number are not going to be significant. Zeros to the left will be. So if I had 0.00023, I only have 2 significant digits, but if I had 0.23000, I'd have 5 significant digits. If I had 23000, I would have 2 significant digits. If I had 23000 point, I would have 5 significant digits. Okay, so those are some of our significant digit rules. The next part of the chapter has to do with precision. Precision. So if I'm using a chainsaw to cut something, I'm going to be less precise than if I'm using some razor blade to cut a similar thing. And so that's what precision is all about. And precision has to do with the last significant digit. So if I had 374 feet, then my precision would be 1 foot. If I had 5,280 meters, then my precision would be 10 meters. Because the 0 is not significant, I am only correct within 10 meters of my answer. And that's what precision is about. So now we're going to look at the exercise for section 4. And we're going to look at problem number 12. Problem number 12, page 16. And we have 205,000 ohms, 205,000 ohms. Now, as an electronic person, you wouldn't write it there. You'd write it like 205 k ohms is what you would write it as. But this is a math book, so it's going to do that. It wants to know the accuracy and the number of significant digits. Okay, so the number of significant digits is 3, and the accuracy is going to be down to 1,000 ohms. Or, if you'd rather, you could call the accuracy as being 1 kilo ohm. You could do that too. You have to have a better pen than mine, though. And the next problem is number 22. Number 22 wants to find the precision, 0.050 kilometers, so that would be 10 meters of precision. No, it would not be 10 meters of precision, would it? It would be 1 meter, because that 0 sitting past to the right side of the 5 is significant. So because this 0 is significant, I'm down to 1 meter of precision. Okay, we're going to look at number 38. And number 38, we want to find the number that's least accurate and the number that is least precise. Okay, so we have 284.0 miles. We have 6.35 miles. We have 7.000 miles. and we have 0.05 miles. Okay, we'll go and make these guys a little bit prettier. Alright, so now we have significant digits and we have accuracy. So we'll look at that. And so I have 4 significant digits, 3 significant digits, 4 again, 4 significant digits, 1 significant digit. I'm good to 1/10 of a mile. I'm good to 1/100th of a mile. I'm good to 1,000th of a mile. And I'm good to 1/100th of a mile. So that's how accurate I am in my calculations. And now the question is, which one of these guys is the least accurate? So least accurate would be the 1/10 of a mile, because that should have a 0 sitting there, 1/10 of a mile. So this guy's least. We don't want least accurate, we want most accurate. Alright, well, let's answer the question then. The most accurate. Most accurate would be the guy, would be that guy. He's got 4 significant digits, and he's going to get down to 1,000th of a mile. Okay, so most accurate, most precise, most precise, most precise. 4 significant digits. And he said find the measurement that is the most accurate. Most precise. What problem am I doing? I'm doing 38. Okay, obviously I'm reading the wrong instructions, so I'll read the right instructions. We're looking for the least accurate and the least precise. Okay, so the least accurate would be the guy with only 1 significant digit. Least accurate. And the guy that's most precise, his least precise would be the guy that only gets to 1/10 of a mile. Least precise. Okay. And with that, we're done with section 1-4, and we're going to section 1.5, which has to do with operations with measurements. So if I'm using units and I'm adding or subtracting those numbers with units, I need the same unit. So I can't, if I have 3 miles, 2 miles, if I have 3 miles and I'm going to add 4 inches, I can't say that that is going to be 7 something. I have to change the miles to inches and the inches to miles before I add them together. Okay, so I got 3 kilograms plus 50 grams. Okay, I can't add those. I gotta go 3,000 grams plus 50 grams. Now the units are the same, and I can get 3,050 grams. Now I could have thought about it and done it in my head, not necessarily wrote it down, but I'm going to have to end up with the same units, 3.05 kilograms. Okay, I'm going to have to do that. If I'm going to multiply or divide the units, then that would be another thing. If I had 2 feet and I times 2 inches, I wouldn't call that 4 feet inches because that would not make any sense. But I could change this to 24 inches times 2 inches, and I could have 48 inches squared. That would be perfectly okay to do. 48 inches squared. Or I could, conversely, I could say 2 feet plus 1/6 of a foot. And we're multiplying these, so we have to multiply times 1/5 of a foot, and then I could have 1/3 of a foot squared. I could do that. That would be perfectly okay to do. When I'm multiplying, I want to keep significant digits. So I have, in this problem, I have one significant digit in both places. And when I get done with the problem, I want to have one significant digit. So I'd probably change this to 50 inches squared because I only have one significant digit in the problem. I would carry one significant digit in my final answer. Okay, looking at the problems in section 1-5, we're looking at number 6. Okay, number 6, I'm adding 7.639 miles and 14.48 miles, 1.004 miles, and 0.68 miles. Alright, so I'm going to add those together. And what am I going to get? 3, 1 to carry, 9, 1 to carry, 7, 1 to carry, 3, 1 to carry 2 miles. Now, I'm measuring these guys to a thousandth of a mile, but these other guys I'm only measuring to a hundredth of a mile, so my answer is going to have to end up with a hundredth of a mile answer. So my final answer is going to be 23.79 miles based on the guy, the number that is the most precise number, the least precise number that I have. Okay, I'm looking at problem 19. Okay, problem number 19. I have 4 pieces of metal, 0.149 inches, and I'm gonna bolt them together. 0.407 inches, 1.028 inches, 0.77 inches. Alright, well, I could put that in my calculator and come up with an answer. I'm going to choose to do it in my head. 9 and 15. 4, 2 to carry. 5, 1 to carry. 3, 1 to carry. 2 inches. Now, we only have we're only accurate to the 100th, so my final answer, if I get the right color here. Okay, so my final answer would be 2.35 inches. Okay, I'm gonna do something weird here. We're gonna make the screen be a little smaller. Okay, now I don't think it's going to jump around as much. So there's 19. We're going to do number 26 next. Number 26. Okay, we have 8.2 kilometers. 8.2 kilometers times 6.75. 6.75 kilometers. Now, they're both kilometers. That's perfectly okay. Our final answer is going to be in kilometers squared for our unit. We'll take out our calculator and we'll go 8.2 times 6.75, and we'll end up with 5.35. 5.35. But because we only have two significant digits in the first number, we can only keep two significant digits in our answer. So our answer is going to be, our final answer is going to be 55 kilometers squared. Okay, our last problem is 36. Number 36. We have 190 grams. And we're going to divide by 3.4 centimeters, 1.6 centimeters, and 8.4 centimeters. Okay, so that's our plan. When we get done, our answer is going to be in the units of grams per centimeter cubed. Okay, so we know that. 190 divide by 3.4, divide by 1.6, divide by 8.4, and we get uh-oh, that was very unprofessional. Okay, we're going to get 4.157913165 grams per centimeter cubed, but we only have we only have two significant digits, so we'd call it 4.1 grams per centimeter cubed and call that our final answer. And I'd probably round this up, wouldn't I? Yes, I would. I'd call it to 4.2. I most certainly would do that. Okay, thus ends Chapter 1, Section 4 and 5.